Hi everyone, Brendan here, and I'm going to run through a demo of the Hello World examples on Hedera. So to do so, you'll need to go to Hedera dev/hellofutureworld.js on GitHub, and I'll leave a link in the description or a QR code on screen. And in the README, you should find this open in green pod button. It's a link. So open that in a new tab, and that will start something called Gitpod, which is a wrapper around a Docker container that's just really easy to run and get started. So the benefits of doing this is that you don't have to set up any custom software on your computer. This is basically Visual Studio Code, but it's inside of your browser. It's not running on your computer. Rather, you are receiving a web page that is inside of a Docker container that is run by or managed by Gitpod. So when it starts up, you'll just have to wait for the scripts to complete. It's doing several things in the background, right? In particular, a setup script that I have configured so that it is easy to get started. Minimal inputs required from you. And speaking of minimal inputs, we've got the initialization script of the .env file, and the .env file is used to store certain configurations that the examples will make use of. So you can open it over here in the file navigation area, and you can see things like seed phrase, RPC URL, account details, etc. Right? So we're going to be setting that up not manually, but rather through interactive prompts. So it says, please enter the values requested, this purple line of text, right? So let's just follow. So most of them, you should be able to just accept the defaults. So for BIP39 seed phrase, it is used to generate accounts from using generating random numbers for private keys, then derive public keys, and then from there you get accounts. So this is just a bunch of dictionary words. Hit enter to generate some random dictionary words, and that will be a seed phrase. So all you have to do is hit enter. So default number of accounts to generate. So let's just accept 3 as the default. JSON RPC URL. So this will actually run in the background for you over here. And you don't need to do anything, just need to hit enter, and it'll tell you, okay, this is it. If you want to use a custom one, then you can use something other than the default. And then for operator account private key, if you want to use the default, which is just the first account that has been generated from the seed phrase, hit enter. That's the easiest thing to do. All right. So now the next thing is a little bit trickier. It's generated this account for you, but this account doesn't exist on Hedera testnet just yet. It is local only, so only this computer is aware of it, and you can't really do anything with that. It has to be on the network, and the way to get it created on the network, or one way to do it, is to fund the account with testnet HBAR. So once you send a transaction to an account, then it is fully operational. So select this EVM address, which begins with 0x and is in bold, and copy that using Command C or Control C, depending on your operating system. Then go to this URL, faucet.hedera.com, hold down Command or Control, and then click on it, and that'll open it up in a new tab. Over here, you can see receive testnet HBAR, and you have a text field where you can enter wallet address. Just hit Command V or Control V to paste your wallet address, and then press the receive 100 testnet HBAR button. Then you'll have to solve this reCAPTCHA, select I'm not a robot, and then press confirm transaction. And after a couple of seconds, you'll see 100 testnet HBAR successfully sent, which is great. Next, press the done button, and you can actually close this tab. Now we're back inside Gitpod and inside VS Code terminal, right? This account has been created and funded now. We're sure of that. Now we hit enter, and it's going to check that account that has been funded, as well as the other 3, as well as create several other accounts. So just let it do its thing, and once it's done, it'll output a proposed new version of the .env file, which is currently quite empty. So just type Y for yes, hit enter, and you'll see that the .env file has been overwritten. That's what we want. And once that's done, it'll also spin up the RPC relay instance. So you can see that that notification has told us about that. So you can see that over there. That's the RPC relay instance running in the background. You didn't have to do much to get that working. All right, so that's the initialization complete, and hope all of you got to this point as well. And if you have any questions, I will be able to help you. For now, let's move on. So we've got 3 code examples over here, in 4 actually. We can transfer HBAR, we can interact with Hedera Consensus Service, we can interact with Hedera Smart Contract Service, or Hedera Token Service. Let's go for Hedera Consensus Service. So we'll open up this file, HCS, and open up script HCS topic.js. And inside the terminal, let's also navigate to this directory. So we'll cd into HCS, and now we'll see that we have this file over here, the one that we're editing. So let's take a look at this file, what it does, right? So it logged a message at the beginning, it reads in the .env file, which is what we created prior, and reads in the values that it needs, and sets up the accounts, and then it does the main thing for this, for the main task of this particular Hello World example, right? So we're going to create a topic, which is effectively a message queue on Hedera Consensus Service, or HCS. So we use topic create transaction, which has been imported from the Hedera SDK over here, right? Topic create transaction. Later on, we'll be making use of topic message submit transaction, which is also imported from the Hedera SDK over here. So topic create transaction, we set a memo, and then we get the transaction ID. Then we sign the transaction using the operator account, which we see over here, right? So this private key for the operator account that was generated from the seed phrase is used to sign that particular transaction. Then it sends it to the network, and then it gets the transaction receipt, and then it prints out the topic ID, right? So that's the first part. So let's go ahead and run that now. So in the terminal, go to type /script, and then hit tab for autocomplete. Press enter, and here we go. So the script has started running, right? We see that over here, and we can see that it has detected our account, which is a result of reading in the values from the .env file over here. And it's saying, I'm going to create a new HCS topic in purple. Now underneath it, you will see a file URL. If you hold down Command or Control and click on it, that will jump you to where that log message was output. And you'll see exactly the code that is about to be executed. So you can preview it if you like. So when we're ready, let's press return or enter key, and that will run those things, right? So it'll say, I've done all of these things, and now the next one, I'm going to Command or Control click, and it'll say, now I'm ready to publish a message onto the HCS topic that has just been created. So for this, we'll use topic message submit transaction, which is from the SDK. We'll set a transaction memo, topic ID, as well as a message, this being the important one. This is the actual content of what goes into the message queue. And then the rest of it is pretty similar, right? So we extract the transaction ID, we sign it using the same private key, we submit it to the network, we get the receipt, and then from the receipt, this time we extract a sequence number, which we're expecting to be 1 unless someone else has submitted to this message as well. And finally, we close the SDK client. So let's hit enter. So it's generated a message, and it says, okay, the message submit create transaction ID is this, and is also got the sequence number for that particular message. Now, the last thing is that it is going to tell you to look at it on Hashcan. Hashcan is the network explorer. So if you're familiar with things like Etherscan, so Hashcan is basically Hedera's version of that, right? It'll allow you to look at transactions, blocks, smart contracts, etc. Well, in this case, we're going to take a look at a message queue, which is our HCS topic. So it's printed out the topic URL, or rather I should say it will do so. So it's saying, let's open up this URL. So I'm going to hold down Command or Control and click on this, and then I will press open, and that'll open it in a new tab. And we can see our brand new topic over here, and it has the memo, Hello Future World topic, which is great. And then we will also see topic messages, and for now we only see one, which is Hello HCS, and that's the message that we just submitted. All right, let's go back to Gitpod. Back in the terminal, it says get topic data from the Hedera mirror node. So Hedera mirror nodes are an API that you can query using simple HTTP requests, and it will respond with data about the Hedera network. And in fact, what you've just seen here on Hashcan, this is essentially a UI wrapper around the Hedera mirror node APIs. So this is a programmatic way of querying the same data. So this is what it does. It constructs a request URL, which basically looks like this, and we're substituting in the topic ID into that URL, and then we're using a standard fetch to make a HTTP request, and then parsing the responses in order to get the number of messages, as well as to extract the messages and the sequence numbers. So let's go ahead and do that. And we can see here that it has queried this particular node API URL, and that's our topic ID over there. And it says we have got one message retrieved from the HCS topic, and now it has listed all the messages, which is just sequence number 1 is Hello HCS, and that corresponds exactly to what we see over here. All right, so it's saying that we've completed the script, and now it's time to see our summary metrics. So while we were going through this code example, this script has been tracking exactly how long we've taken to complete each of the steps. And this is important to know, so that you know how difficult it is by virtue of how fast you can get through the script and complete it, right? So let's take a look at that, right? So the first task that we've completed is this one over here, and it took a total of 11 minutes. That's including explanations. Now without explanations, that's probably going to be under 5 minutes. So, and we can see that the actual task itself for HCS topic only took about 4 minutes. The other 7 minutes was actually the time it took for Gitpod to spin up, as well as for us to initialize the .env file and run the RPC relay. So all the background setup tasks took us about 7 minutes. All right, so we can actually see our metrics on chain as well, right? And not to worry, it's been completely anonymized, so this is how you know which messages correspond to yourself. Now, we've completed the HCS Hello World example, and let's go ahead to the next one. So let's navigate back to the root directory, which is just do cd ... in the command. Now for the next one, let's take a look at HTS, Hedera Token Service. Let's open up this file over here, script HTS FT, FT standing for fungible token in this case. So we're going to create a fungible token on Hedera Token Service. Note that unlike other networks, in Hedera you do not need a smart contract in order to create a token. And despite that, the tokens that you create are still compatible with the ERC20 ABI for the case of fungible tokens, and it's also compatible with ERC721 ABI in the case of non-fungible tokens. So in this case, we'll be creating a fungible token. So again, we are going to use the Hedera SDK, and from that we will import a token create transaction, and we'll send that transaction later on. So let's also navigate to that. So cd HTS, and you will see these two files over here. Now let's take a look at this file before we run it. So it says this is the hello world example for HTS fungible token, and this is the initialization, same as what we saw earlier on with HCS, and we're reading in the .env file to initialize the operator account, among other things. All right, so now we're ready to actually do the first transaction, which of this example, which is to create a HTS token. Fortunately, this is really easy. Effectively, we use a token create transaction, and we use dot methods and chain them, and each method simply adds a configuration value to the transaction. So we'll set a transaction memo, we'll set the token type to fungible common, and so this actually corresponds to a fungible token that is roughly analogous to an ERC20 token, and supports its API. We can set a token name, so we're going to just call it the script ID, which is script HTS fungible token, right? HTSFT, followed by the word coin, and then the token symbol will be HTSFT in all uppercase. We'll give it 2 decimal places, and we'll set the initial supply to 1 million. So with 2 decimal places, we're expecting the initial supply to actually be 10,000 units of this particular token with 2 decimal places. So it's 10,000.00, just like dollars and cents, I guess. Then we'll set the treasury account ID to our own account, and then we'll then complete the transaction, and then we'll extract the transaction ID. We'll sign the transaction using our account. Just to recap, our account has been configured earlier on in this section over here in the .env file, and that was the account that we funded initially via the faucet. So once the transaction has been signed, we send it over to the network, and we obtain the receipt back from the network about what actually happened in the transaction. Hopefully it was a success. And from the receipt, we extract token ID and print it out. All right, let's begin. So let's run /script, hit tab, and then it'll autocomplete to fill in the file name. So it'll be script htsft.js, and let's run that. So hold down Command click to jump to the appropriate line, and it's saying now we're about to do a token create transaction. Let's go ahead and do that. So we've got a token create transaction ID, and we've also got the token ID. So that went pretty quick, right? So we're all the way up to here. So then we can close the client because we're not sending any more transactions. And then now we're going to verify the transaction on Hashscan, right? So we're up to here, right? And so let's run that, and all it'll do is print out a URL. So let's hold on Command or Control and click on that and press open. And we'll see a fungible token over here which says HTSFT coin, right, which is what we configured. And over here we have 2 decimal places with 1 million units. So that corresponds to 10,000 whole numbers of it, with the two decimal places corresponding to the cents effectively. And we can see here that just our own account holds the entire balance of, since it's the treasury account. So the initial mint of the fungible tokens all went to our account, and it's up to us to distribute that to token holders or sell it. And yeah, we created a fungible token from scratch just using this one configuration. We didn't have to write any Solidity code. This replaces all of that. And then a few more lines of code to sign and send a transaction and get a receipt, and voila, we have a token already, right? Now the next step is Hedera Mirror Node, right? Which, like I said before, basically is the API, the underlying API from which we are able to visually see what is on Hashcan. So let's hit enter, and that will query the Hedera mirror node with this particular URL, and it'll extract these values from it. So it says the name of the token is that, and the total supply of the tokens is that, right? And you can see that's 1 million total, or 10,000 including 2 decimal places. Now let's take a look at the summary metrics before we wrap up. So we can see here that the second task that we completed was for HCS fungible tokens, and that took us a total of about 2 minutes. Excellent. So for this demo, I'd like to do one more, and to do that, let's cd one level up, and we can close this one. Now let's go to HSCS, which is Hedera Smart Contract Service. Let's open up this time a Solidity file that has been provided for you, as well as the script file. And inside of the terminal, let's cd into HSCS, and here we can see all of the files that are available here. So these are the 2 files, this one and this one. These are the 2 files that we have open at the moment. So let's take a look at this smart contract. It is a very basic smart contract. It has a constant value. It also has a mapping, which is effectively a hash map, for those of you who are familiar with that, of where the key is an EVM address and a value of a string. Whenever you introduce yourself, it writes the value into this mapping, and whenever you call the greet function, it reads the value out of the mapping and responds with that, with a prepended hello future, piece of text in front of your name. Okay, so that's the smart contract. It is very basic, doesn't do very much, but it's sufficient for the purposes of demonstrating Hedera's smart contract service and its EVM compatibility, right? So let's run this contract straight away and just take the steps one at a time. Now, the first time we run this, we're going to be expecting an error. I just wanted to demonstrate what that looks like. So let's run inside of the terminal, type /script followed by the tab key to autocomplete, and that you should see script HCS smart contract js.js, right? All right, so it initializes the operator account and it reads in the compiled smart contract artifacts, right? So it's reading in the .abi file and the .bin file, which, by the way, do not exist yet, right? And so we hit return when ready to proceed, and we're expecting an error to occur right about now, right? So it's saying no such file or directory. It couldn't read in the ABI file, and even if it could, it wouldn't have been able to read in any one of the other artifacts. So what we need to do now is we need to run the Solidity compiler, right? And now we're going to be using the standard Sol-C.js, the Solidity compiler that is used on Ethereum and every other EVM-compatible network. We're not using a customized one here for Hedera. It's just the same one that everyone else uses, right? So inside of the package JSON, right, we're going to run that Solidity compiler that we've installed over here, and we're going to run it with the ABI and bin flags so that it generates those files with the input as this file over here, mycontract.sol, right? So this command is already there and we just need to run it. So npm run compile smart contract. Run that. And so that runs this command over here. And now if we look at the same folder, we'll see that there are 2 new files, the ABI file and the bin file. And this is what we want. So now, when we go back to the script and we rerun this, we're expecting that error that we saw earlier on not to occur anymore. So let's rerun the script, /script, hit tab again for autocomplete, and then run it. All right, so this time we're back at the same spot, and it's trying to read in the ABI file as well as the bytecode, and let's see what it does. All right, so it has found the compiled smart contract ABI, so this is a truncated version of it, and it's also found the compiled smart contract EVM bytecode, and this is the truncated version of it. let's actually take a look at those files. So the ABI here, this is intended to be human readable. This is the bin file, and this is the EVM bytecode. This is not intended to be human readable. But this is what actually executes when the smart contract is invoked on chain. All right, let's deploy the smart contract. Excellent. So notice here, I should have mentioned this at the beginning, that we're using Contract Factory. Where does that come from? It comes from Ethers.js, which is over here, right? So notably, we have not imported the Hedera SDK in the script file at all. We're completing this entire task completely using Ethereum developer tools or EVM developer tools. We could also use the Hedera SDK to do this, but I figured that it would be of interest to actually demonstrate that the level of compatibility of Hedera with EVM dev tooling. All right, so let's continue. So now we have deployed the smart contract over here to the network, right? And I'm going to hold down Command or Control and click on the hashcan URL over here, and you will see that there is a smart contract over here. We can see the smart contract ID, and as well as its EVM address. We'll see that it has one call, which is basically the deployment that we have just done, and this is the bytecode that we've seen over here. And this is, the bytecode using a different like a parsed version of the bytecode, the hexadecimal opcodes. That's what we see in the smart contract. Now, I should also mention that the smart contract is not verified. That's the reason why you can't see the source code here, but that's beyond the scope of a Hello World example. So we can take a look at that later if you want. So let's write the data to the smart contract, right? So this is where we're going to be invoking the introduce function, right? Which actually updates the state of the smart contract. Let's go back to Gitpod, and you can see over here what it's actually going to do. So the deployed smart contract, it's calling the introduce function, and it's passing in this value, right? So it's passing in a version number of this particular script, as well as the script ID. And then we're using the Ethers.js way of submitting the transaction to the network, which is .wait, and then it is going to calculate the transaction fee. That's a little bit complex, so I've moved that out into its own function. And then we are going to look at it in hashcan as well, the transaction. So let's go ahead and do all of that. So this transaction is actually interacting with the smart contract, and we can see, okay, so it has used up 0.01 of a H-bar, so that's a fraction of a cent in terms of actual dollar costs. This is the transaction hash for that interaction with the smart contract. So if we hold down Command or Control and click on the hashcan URL, that'll show that will display that to us visually. So we can see there's been a transaction. It's an EVM transaction, as we can see over here, and we can see that it has succeeded. We can also see like further details, but these details aren't exactly human readable because we haven't verified the smart contract. However, we will know that it has worked if the next step produces the result that we want, right? So that's where we read data from smart contract, which is over here. And so here we're using Ethers.js to invoke the greet function, which is this function over here, which extracts the name from the mapping and then says hello future followed by that value that was stored in the mapping, right? Let's go ahead and do that. This one should be much faster since there was no transaction involved, because it's a query rather than a transaction. All right, so the read result was hello future followed by the version number followed by the script ID, which is exactly what we expected, because in the write transaction we passed in the version number plus the script ID. All right, so we've completed the smart contract example. Let's take a look at the summary metrics. So I'm expecting this one to take a little longer. So for the Hedera smart contract service example, that took us almost 7 minutes in total, but it actually only really took us 5 minutes. The first 2 minutes were because of the error. So we had one error prior to completion. So that's the end of that one. So I'd just like to wrap up by showing you the summary metrics across everything, right? All the examples that we've completed at least one task. The first one to complete was HCS, and for all tasks to complete, it took us a total of 28.5 minutes, which is pretty remarkable, right? We've done the setup, and we've completed 3 examples, 3 Hello World examples spanning all the 3 Hedera services, including explanations, and all of that all in took under half an hour. All right, that's it. Thank you very much for watching. Ciao.